Curvature over the horizon. One of the most common flat earth proofs. Where is the curve? When discussing earth curvature, you are exploring how far you can see beyond the horizon. So I created a small animation here, and I have the earth, or a model of the earth, just a sphere, rolling by. It's actually spinning, and you can see it spinning in that direction. And you see the lighthouse just coming across the horizon. And you saw how it came up over the horizon as we traveled over the curve, and the lighthouse was a bit tilted. So now we're going to go on until we get to the sailboat. You see the sailboat here, and you saw how the sailboat came above the curve, okay, as we traveled over the curve. And this is a very common idea. The reason why you see things disappear over the curve or over the horizon or reappear over the horizon is due to the curvature of the earth. So let's explore that. All right, so now we see a scene here of a sailboat, and the sailboat is right on the horizon. And if you notice here, there is no mirage, there is no distortion due to temperature differentials. Um, you can just see the boat. There's no inverted image or anything like that. You just see the boat on the waves. So as the camera zooms back, okay, toward me, as I zoom out, then you can clearly see that, voila, there is nothing on the horizon. Um, According to modern science, that means the boat is beyond the curve. And you saw in the animation that uh, 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 your line of sight is straight. Okay, you cannot see beyond the curve. All right, we cannot do that. So if something is beyond the curve, it doesn't matter how far I zoom in, I'm not going to see it. All right, yet I was able to zoom in on that sailboat with no problem. All right, here we have another image, and as you can see, there is nothing on the horizon. All right, but we're going to zoom in, and this image is opposite, so we're going to zoom in. This is Lake Erie, and so I zoomed in, and voila, there you have it. You see a sailboat, and there's a motorboat. Looks like some people on some jet skis here, just floating there. So there was nothing on the horizon at first, and as I zoomed in, they appeared. Why? Because, oh, that's very cool. Because because my line of sight is straight ahead. Now I'm zooming right back out, and as you can see, they disappear again. According to modern science, they are on the other side of a curve of water. All right. Yet I was able to zoom in on them with no problem. Look at this. There's nothing there. So now we're going to go on to the next view. Okay, we have another water view. And the reason I use water is because water is always flat. All right, water seeks its own level. It's always flat. So water is an easy way to experiment with curvature. So as you can see, there's nothing here on the horizon. So now I'm going to zoom in, and the second here, and yeah, that's the proper view right there. Okay, so I'm going to zoom in, and as you can see, we actually see two ships. I'm not sure what these are, but there are two ships on the horizon. As you can see, there is no distortion on the hull of the ship. Look at that. There's no distortion at all. Now you see this waviness here. That's due to telescopic compression. When you're using an extreme zoom lens, I'm using the P1000 here, and I am way beyond 3000 millimeter, because the P1000 can actually go beyond 3000 millimeters. So I'm using the digital zoom. And as you can see here, you have all this waviness here, and that's because it's compressing perspective. The air is always moving, and when you use an extreme telescopic lens, it simply emphasizes that movement, and that's why it looks like the boat is, well, underwater, because air is basically thin water. It's very thin, instead of being thick like the water. And if you notice, the waves here are much higher and they look choppier. And they actually aren't. It's because the telescopic compression, the lens is compressing perspective and causing all the waves out there to look like they're basically on one plane, which kind of jumbles them up, and it accentuates the movement that's there. So now I'm going to zoom back out again, and it was really windy out there, so excuse my jittery lens here. And as you can see, there's nothing on the horizon. So let's move on to the next shot. Here we have a scene from a suburb, and we're looking at downtown Cleveland in the distance, as you can see there, and we're some miles away. Now, we can clearly see downtown Cleveland, but this is not a curvature test. This is more of an angle test, because the if you remember with the lighthouse in the animation, as we traveled along the curve, the lighthouse, as it became viewable, it 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 looked as if it tilted backward. And as we travel closer to it, it straightened up. That's because it was on a curve. That's the way it should look when it's actually on the curve. So we have downtown Cleveland pretty far away here. So it should have some type of tilt to it, tilting backward away from the camera. So let's check it out and see if that's true. So we're going to zoom in on it. And there's Cleveland, and we're going to zoom in on it. All right, and then we're going to put some lines up against it, and these lines are perfectly perpendicular. So as you can see, it is completely straight. All right, it is completely straight. Completely straight. There's no angle to it at all, and but there should be some, and these perpendicular lines show that there is no angle to it at all. So, what is our conclusion? All right, due to a few simple, observable, repeatable experiments, the simple conclusion is there is no curve. It is as flat as it looks. So, basically, that's what we have here. This was another shot of Lake Erie. My wife and I spent a pretty hot day that day. It was pretty hot. So, but as you can see, there is no curve. It's as flat as it looks. So, in conclusion, as usual, don't accept, verify.